In the previous lesson, we applied vertical and horizontal stretches and compressions into the sine and cosine functions. Today, we're also going to look at some shifting vertically and horizontally, and we're going to combine the stretching and compressing as well. So just like with regular functions, we can shift vertically if we have what we refer to as the c value. Now, that c value will shift it up or down the function. And if you take a look at where it is located, remember that the c value is outside of the function. So sine x plus c or cosine x plus c is what that would look like. For horizontal shifting, we actually call this a phase shift when we're dealing with sinusoidal functions. It'll look a little something like this. So x minus d inside the function. So sine x minus d or cosine x minus d. So remember that horizontal transformations occur inside the function. Just remember that it's always kind of the opposite of what it looks like. So if you see x minus d, such as x minus 2, that actually means you're going to be shifting to the right 2. If you see something like x plus d, that actually means that your d value is negative and you'll be shifting to the left. What we saw back in the functions unit is that these translations do not affect the shape of the graph. It just shifts it left, right, up, or down. So because it doesn't affect the shape of the sine or cosine graphs, it will not affect the period or amplitude. So just like with functions, we're going to apply transformations in the proper order using order of operations, and we're going to be using our mapping notation. So remember that any point xy becomes, the first thing that happens to x is it gets divided by the k value, and then we can either add or subtract the d value depending on if it's left or right. The y value gets multiplied by a, and then we add the c value or subtract the c value if it's shifting down. So remember that the division and multiplication have to happen first, and then the addition or subtraction. So what we're going to do, we're going to graph this function in the video, f of x equals 2 sine x minus 1. One of the tricky things about graphing these, we talked about it in the previous lesson, is coming up with a scale so that we can fit in one cycle of our graph and it looks nice, big, and neat. So in order to do that, we are going to first determine the period and the amplitude of this function. That's going to help us determine our scale. So first off, I showed you this equation in the previous lesson. We can figure out the period by taking 360 degrees and dividing by the k value. In this case here, if you take a look at the function 2 times sine x, there's no operation happening to x. There's no multiplication, it's not 3x, there's no division, it's not 1 over 3x, anything like that. So our k value in this case is simply 1. Our period is going to stay as 360 degrees. So when I come up with my scale for the x-axis, 360 degrees is all I need to fit. In terms of the amplitude, what we figured out yesterday, or in the previous lesson, is that the amplitude is the same as the a value. And if you take a look at the equation, the a value is 2. So what that means is I'm going to have a maximum value of 2 and a minimum value of negative 2. But there's going to be something else happening to this function. We have a shift downwards of 1 unit. So instead of having a maximum value of 2, it's then going to be a maximum value of 1 because it's going down 1. And instead of having a minimum value of negative 2, it's going to be going down 1 to negative 3. So I know that my y values, I have to be able to fit in 1 to negative 3. That's where the max and min are going to be. So just a little bit of planning ahead of time and we can come up with our scale. So as I said, I'm going to fit in 360 degrees on the x-axis, and I have to make sure that 1 to negative 3 fit on my y-axis. So I'm going to pause the video and then fill that out. All right, so here's my scale here. So I'm using up all the space that I can to make the graph nice and big. So what we're going to do now, we're going to write out the mapping notation and then we'll graph all the points. So what I've done down here is I've written out all the original points, all the key points for the sine function. Notice how I have the degree symbol for all the x values. That's going to be very important for communication purposes. All right, so in terms of the mapping notation, going back up here, there's really nothing happening to our x values at all. There's no k value, there's no d value. So my x value will just stay as, the same thing. But what's happening to the y value? So this is my a value, that's going to multiply y. This is my c value, that's going to subtract. So it'll be 2 times y and then minus 1. So at this point, I can just complete my mapping notation, and I'm going to pause the video and do that. So here's all my points. Again, as I transform it, I still have the degree symbols on my x values. Okay, again, very important. So what you'll notice here is we can see already that because the x values are not changing, I still have 0, 90 degrees, 180, and so on. But the y values are different. There is a pattern though. I go from -1 to 1, back to -1, -3, and then back to -1. So I'm now going to plot the points on my graph, and we'll take a closer look at that. And here is my function. So it is still periodic. We are still beginning and ending at the same y value, and this function will repeat itself over and over. One thing that's different about this transformation, that's different than what we did the previous day, if I were to draw the axis for this curve, it would go about here. And this equation is y equals -1. So I do have an amplitude of 2 because there's a distance of 2 to both the max and the min and my axis. But now the axis is different. It's -1. So what has happened to that? It has shifted downwards by 1 unit, which is the exact same thing as the function. So if you think about it, the axis y equals 0 is not affected by any stretches or compressions, but it can be shifted. We saw that before with the asymptotes of the function 1 over x. All right, so this is the basics for graphing all of our transformations. We'll practice a few more in class.